Well, thank you everyone for joining us for our April ChicagoRuby meetup. We aim to meet every first Wednesday of the month. And we want to thank Tegus for letting us use this space and for being such a gracious host. With that, I will hand off the mic to Adam. No, yes. Sorry, Adam. Here you are.
Hi, everybody. I'm Adam Forsyth. I'm a principal engineer here at AlphaSense. All the Tegus stuff is a lie. We were bought last year. We were a Chicago headquartered company. We still have a very large engineering presence here, and we are hiring. If you are looking for a job, generally at the sort of mid to senior level, but I think a relatively broad range of skills right now, we have a number of open roles. If you are interested, you should reach out to me and I will get you a referral link, which sort of puts you at the top of the pile. So yeah, if you're interested, please come talk to me. I've been here over 3 years. It's been pretty good. We get less stock at AlphaSense, but they pay us a lot higher salary. So, you know, perks of the new setup as well. Yeah, feel free to come talk to me later if you're interested. Have a great time tonight.
Cool. Thanks, Adam. All right. Some items just to get us started. All right. First off, join us for our future events. We'll post our events through meetup.com, linked over there, as well as our Slack channels, Meetup USA Midwest on the Ruby Central Community Slack. DM or talk to me if you don't have access to the Ruby Central Community Slack. I'll get you added there, as well as the Ruby channel on Chicago Tech Slack. Next thing. Oh, okay. Are you interested in hosting? Well, we're looking for organizations to host our monthly meetings. If you're interested, or if your company is interested, reach out to Anton or Daniel, who's not here, or myself. Other thing, we want to hear from you. This is a fairly new slide, so bear with me. Okay. If you're interested in speaking, definitely excited to have you as a speaker. If you're interested in speaking, but you're unsure of a topic, or if you want to just hear a potential topic that someone might want to talk about, we compiled a list of potential topic ideas that members of the community are interested in learning more about. So feel free to add your ideas here. I have a QR code over there as well as a short URL. It links to a Google spreadsheet. That spreadsheet is open for comments only, just for moderation purposes. I'll add, or any of the admins will add your topic ideas as like a formal item on that list. Yeah. And actually, talking about hearing from you, I'm going to have this open forum right now for anyone who has anything they want to share. All right. Go for it, Josh. Here.
Hi, everybody. I'm Josh Austin. I work at Power Reviews, which is a one-world sync company. We maintain a website called buzzagent.com, which is a product sampling website and application. It is built in Rails, and we're hiring. We are looking for a senior engineer. So if anybody's interested in joining my team, feel free to reach out to me in person or reach out to me on LinkedIn through the username Josh Austin Tech.
Cool beans. Thank you. Thank you. Last thing, or no, not second to last thing. Yeah, if you're interested in supporting ChicagoRuby, either by hosting a different type of event other than this speaker forum, something like a hack night or a board game night or a code and coffee, we are so down. Let us know and let us support you. If you're interested, feel free to reach out. Other ways you can support us is monetarily. So if you want to fund us for food, for different events, speakers, or getting travel reimbursements for speakers that come out of town, marketing, AV tech, meetup fees, etc., stuff like that. Reach out to me and I will give you more info. And lastly, join us next month. We have 2 really great speakers. Next month our meetup will be on May 7th, Wednesday, 6 p.m. to 8 p.m. at Avant. Hopefully I said that right, which is in Merchandise Mart, very close to where we are. Yeah, and that's pretty much it. I don't know if you had a question no, you were just, yeah, never mind. Yeah, and with that, I will hand off this mic to Lionel and stop sharing my screen.
All right. Hey, everyone. Still visible on Zoom? All right, cool. Okay. Well, thanks, everyone. Thanks for having me. By the way, I just wanted to plug, everyone do take advantage of Adam's referral link. Basically, the whole way stuff like this works from a company's perspective is that they're like, this is a marketing tool for hiring people. So if we can say, oh, we got all these people through the funnel or into our hiring funnel based on hosting a meetup, we can buy even more pizza next time around. Or I say we. It's not actually we anymore, but I'll get to that. So this is a talk on doing a modular monolith pattern in Rails applications. I've given this talk a number of times. That's why it kind of says, like updated timelines here, including actually at ChicagoRuby like 7 or 6 years ago or something like that. Yeah, so that means that there's now more reflection and introspection on how things went in the talk, which is good. Okay, let me just have to minimize this thing. There's a bunch of crap on my screen. Hide. Okay, cool. Okay, so who am I? As Adam mentioned, I'm the former head of engineering here at Tegus. So I was the VP of engineering. I ran the team here for 6 years, more or less. And I think that also relevant for this conversation, I was the first engineer. So I built a bunch of the original systems. I built the original team. And we kind of had a lot of intentional discussion around how we wanted these systems to look as we grew, which feeds directly kind of into what we're going to talk about tonight. I'm currently kind of bouncing around, doing some consulting, some nonprofits, some advising, that sort of thing. I'm also a clinical professor at the University of Chicago's MPCS program. This is the graduate software engineering focused degree program where I teach classes on cloud computing and software testing. So I don't know, yeah, I'm just kind of like in software hanging out. So we're going to talk about mostly the stuff that we did at Tegus in this talk, which is, it's a little odd because I don't work here anymore, but whatever. I still am able to talk about this, I think, in a fair amount of detail. Yeah, so as mentioned, I've given this talk several times, and this means that I can kind of refine it, which has been good. We can kind of say like, hey, it's one thing to kind of say, oh, hey, we invented this cool new technique. That's actually that happens a lot in software development. Someone has an idea, they're like, let's try this out. Let's like organize our code base around this like, thing I invented. But it's another thing to kind of say, all right, we did that for half a decade with probably, I'd say, about 150 engineers working in this code base over the course of that half decade. I think because we probably capped out at like, I don't know, 120, maybe 110 like concurrent people, but people come and leave over 6 years. So it's like you have lots of people working this thing. Then you can say, okay, well, after that amount of time and like that, moderate scale, what actually happened? How did it work? That sort of thing. So I think that it's good that this is like the 5th time I've given this talk or whatever it is. Yeah, but I don't have as many screenshots of code as I used to. But that's fine because this is like a architectural discussion, right? So it's a little less relevant. So to frame how I think about this stuff, I think that big picture, system design, architectural stuff, programming languages, frameworks, all these sorts of things that are like core, like basic decisions you make when you sit down to build a system, or in our case, like to build a company. You really have to think carefully about the goals you have. And the goals here that I like when I was kind of doing this with the initial core engineering team, it's like, all right, we want to design a system that's really productive, right? We want to make it really easy for people to come in, see how things work, make changes, and for those changes to be made quickly, safely, easily. They should be easy to test. It should also be easy to deploy and operate the system that we're building. We want there's this tendency, I think, sometimes where software developers can really optimize for like how easy it is to do something when you're typing code on the keyboard at the expense of what it's like to deploy and operate that code once you deploy it, right? So we were like, we want to have both. We want to have a system that's easy to operate and a system that's easy to build. And we wanted to minimize self-inflicted complexity. A lot of people from the core Tegus team way back in the day kind of came from the same place. We all were engineers at Braintree, which was then PayPal, which is where I found Adam. Years later, Adam wasn't, Adam joined, I don't know, we were already off to the races by that point. But we really had, like, Braintree was great company, but also had like a lot of really complicated systems. And we were kind of like, do we need this complexity? Is there a way we can kind of build a system that has less complexity, that we spend less time worrying about that and more time worrying about like the business features that we're trying to build? And we knew it would be a marathon, right? That's one of the, I think, the key things that you kind of learn as you mature as an engineer, is that this stuff, it's like, it plays out over years and years and years. And so we knew that we wanted this to be kind of oriented towards the long haul. So to kind of motivate this, I really like to think about, like, how do systems that we're building as engineers evolve? How do they grow over time? And in the particular context of Rails, like, Rails has this, it's not unique to Rails. It wasn't invented by it. This is a joke, by the way. DHH did not invent Ruby or the MVC pattern. People don't even catch that. But like, Rails, it uses the MVC pattern, which means that we kind of have like a horizontally oriented system structure, right? So by that, I mean, controllers, that's like a layer of the onion of your application. We put all the controllers together in one area by default, right, in Rails. And then all the models also, that's another layer. They go all in one folder by default, right? That's kind of what I mean. View is the same thing, right? So that's MVC. You organize the strata of your app become also the kind of like execution strata, going from like entrance point to controller routing layer down to like logical layer down to the database and then back up. That's also like the way that the code base is organized. And that's pretty good. Like, when it's a simple application, this is like very fast. Rails is famously very easy to get up and running quickly with. Like, that's kind of part of how it has attracted so many fans. But it famously can have difficulty growing. And so, you add more stuff. And like, the way I like to think about this is like, let's just imagine that, first of all, we're not actively bad. Actively bad software development to me here would be like the arrows here, like the source pointing at the destination means the source depends on the destination, like uses it in some way, right? So actively bad would be like the post controller imports the user's controller and uses it in some way. That'd be really dumb. That's like, you're kind of just really just not trying to have modularity and reuse inside an application. I would relax that a little bit when you're talking about models. Yeah, obviously models do import each other's. That's, let's not ignore that. I forgot to draw the arrows between the models, but you can already see that, like, once you have like 6 boxes here, like 6 things, you start to have a lot of connections, right? You have lots of connections between the different control, like, the likes controller. I'm imagining, I guess, a fake Twitter. Yeah, like the likes. All right, backup microphone, great. Okay, so this can get complicated, right? Like, it's like, if you start to have like lots of connections just between the different layers, right? Between elements of the different layers. And to some extent that makes sense, but to some extent that can become a problem, right? And imagine, again, like, this is a marathon, not a sprint. We want this to work over several years. We want this to work with, like, ideally, like, at least 100 people can work over the code base in that period of time. You're gonna have a lot of boxes, right? You have many, many boxes, lots of stuff going on. And with Ruby, you don't natively have a lot of ways of controlling how these things are done. So you're very much relying on on your developers to have like a really keen sense of discipline, to be like, maybe I don't need to reference, the retweet concept in my likes controller, whatever it is. Maybe maybe you do, maybe you don't. So why is this bad? Yeah, so you have higher and higher degrees of connectivity and coupling. And so this leads to the situation where you can't change one thing without also changing all 7 things that rely on it, right? And again, by default, everything can reference everything in Rails applications. And so you end up with a lot of connections that I would argue are probably, when you actually think about it and you actually do some design, they're extraneous. But these extraneous connections kind of weigh you down. It makes it harder and harder, kind of, it's like, oh, I like change the behavior of this one thing, and then like 15 things that I didn't even know were relying on it broke. And hopefully I have really good tests to tell me about that. And you should still have really good tests, but that's, it's a problem. This happens because context drifts over time. You oftentimes, like Rails, it lacks an obvious paradigm for medium scale design. That is to say, like, not like, oh, like small scale design we all do. It's like this function, it has too many parameters. We should break it into 2 functions. Or we should do partial application to make it so that don't have 7 parameters in the function or 7 arguments. Large scale design is like, I will draw a bunch of boxes on a diagram somewhere, and like we want fewer boxes. That's better designs when there's fewer boxes. Like that sort of thing. I'm talking about medium scale, where it's kind of at the level of like this set of concepts interacts with this set of concepts in the application in this way. Rails doesn't have a natural paradigm for doing that. The natural paradigm is MVC, basically. But MVC is like kind of, I would say, table stakes, and it's like not sufficient even with a moderately large code base. It's easy, yeah, and it's just very easy to call into other parts of the app. So this means that you, and I want to emphasize, it's like, it's not that I think that this stuff happens because developers are doing something wrong per se. It's more that it's kind of like, it's often just expedient. It's like, well, if there's like an actual domain relationship between the retweet concept and like the likes concept, then we need to express that somehow, which means you have to introduce a dependency between one and the other, right? The problem is just that it's not controlled. You don't have a natural way of controlling these dependencies. But actually, very smart engineers have come up with a very good way of controlling these dependencies. We all know what it is. You have to put them in different apps. Put all of the concepts in different apps. Have 17 different services, right? And so now it's like, instead of, you can't have an arrow go from here to here. Or if you do, it's like really obvious that that's like a giant, like that starting to draw this arrow has like, you're like, oh, I have to build like the API that's going to handle network requests to go in and out. I have to think about authentication. I have to think about like, what are the, how does the API express this stuff? There's basically a giant warning label that says like, this is a big system design choice on that process, right? So your engineers are not going to be like, oh, I didn't realize it was important that I add this dependency. It's like, it's really obvious that it's happening. So this does work, right? Like putting all your stuff in different services that are mediated by network hops between them does force people to think more carefully about what is relying on what inside of your domain. Like it does work in that respect. However, it has really significant costs that are not, I would argue, like if you can achieve the same outcome without paying those costs, that seems like a better deal to me. You have many more problems, right? So service-oriented architecture, I think that it is this thing that's, there are some good reasons to do it, which I'll caveat kind of in a minute. But in general, like you have to realize that it introduces significant problems if you're trying to build a software that's like reliable. You have to think about how do deployments work? That question becomes a lot more complicated, right? Because now instead of just having one build and after just kind of reason about like forward complexity of like the database or something like that, as I deploy migrations on my one deployment artifact, I have to think about like, okay, I have 2 apps. Let's just say I only have 2 services. Is the API from A to B compatible when they're both on main? What about when like this one is like 3 commits ahead and then this one is like deployed a little bit later in the day, and so they're not actually, like main to main compatibility is actually only like a tiny subset of the types of interactions you might actually be seeing, right? Like it's like, so when you actually run an integration build and how do you release that stuff, that becomes really complicated. This is where people, like at Braintree, we used to have like a release branch that was separate from like the primary branch. You would have to do like development to release and release to development and development to development and release to release. That's just with 2 apps, right? Nowadays, I think that it's more common to not have a release branch concept. You just kind of say, we're going to do continuous deployment, which by the way, that is a better practice. I endorse that. But it also means that, again, you have to think really carefully about like, okay, if I'm continuously deploying and I have 2 target code bases that are moving at different like speeds, like how do I how can I actually be sure that like the version of app 1 that I'm deploying can actually speak the protocol that app like that the currently deployed version of app 2 does? Or what if app 2 is also simultaneously being deployed? Like that's really annoying. And that's only with 2 apps. What if you have 17, right? Which you could very quickly get to. And that's also just the first bullet of like the 5 bullets I have here of problems. You have to think about distributed transactions. Who here knows what I mean by a distributed transaction? This is like the grossest problem you can run into. Anyone who's not Adam want to give a definition? No? Okay. Distributed transaction is like, we're going to do a thing where we're going to create a user, and then we're going to create, I don't know, like a provisioned, like, what would a user have that would require a thing? Okay, it's like a Twitter bet for dogs. So we're going to do a transaction where we want to create a user in the user service and create a dog in the dog service. And somehow there's a point between the user and the dog, which is, don't worry about it. The point is they're related to each other. They both have to be there. And it's not, the system doesn't allow for the condition that there's a user without a dog, right? It's always expected that they're one-to-one or something like that. Distributed transaction problem is, you're in your service-oriented architecture, the request comes in, you create the user in the user service successfully. And then step 2 is you go to create the dog in the dog service. And something breaks and you can't create the dog. Well, if this was all in one app, well, that's fine. You just roll back the database commit that created the user. That's like not a problem at all. This is like basic, every request should basically be wrapped in an atomic transaction that you're in your relational database. And so it's easy. But if it's across a network hop, you can't do that. You have to either hold the database transaction open while you make all of your downstream calls, or you have to have a protocol for saying, oh crap, the dog creation thing failed, so I have to delete the user that I just made. And like this is going to be in a subsequent API request probably then in that case. So it's just like, that's a lot of coordination. That's like an incredible amount of additional coordination just to maintain a very simple system invariant that, again, in a single app, this is like automatic. You often don't even have to reason about doing this. That's the second bullet point. Third bullet point, distributed request tracing. Who knows what this is? Not Adam. I think a bunch of you all do know what this is. Adding field tags into your request. Yeah. So it's like, this is the problem of like, when I look at Sentry, I want to be able to say this request hit this application and caused this exception. Cool, whatever. What happens if it's like the originating request from the user went through 6 layers of other applications before it blew up? Well, what I really would want to do is I would be able to say like this, every time you do like a network hop there, you're kind of creating a new request, right? Like from the perception of the receiving application. What you have to do is you have to, at your edge layer, say, this is like the user's like request ID. We're going to carry that forward through to each subsequent downstream API call. And then you have to teach your APM and your Sentry and your error manager to understand that, right? Because what you really want to be able to do is like assemble like all 6 stack traces at once to see like what happened. Yeah. It's a request meta tag type thing. Hey, this actually might be the easiest one of the 3 that I've just mentioned to actually do. But it's like, again, if it's just one app, I don't have to have reason about it at all. It's not a concept. Yeah, Adam. We hired the wrong principal engineer. We still don't do that? I thought we did do that. Yeah, not everywhere. Yeah. Okay. Other stuff, internal libraries, like most companies develop internal libraries, or they have, you're using some dependency and it's like not quite the one you have to like fork it to like patch something or something like that. And it's like, oh, well, now we have different versions of them because we have 17 services, and like the team that maintains like this one doesn't think they can get around to upgrading their copy of the library for another 2 months. And this one's like going charging on ahead. So now instead of having like the team that's maintaining this internal library, their life just got much harder because they're not just maintaining one like main copy ahead of like one branch. They have to do a lot of backwards compatibility reasoning about that internal library. And that's assuming, by the way, everyone's in the same like Ruby version or like all that sort of stuff, right? Which is like, again, maybe not safe to assume. So there's a lot of complexity here, right? And the idea is that we do all of this because it is a way of doing that. It's a way of forcing boundaries on what developers can talk to each other on in order to constrain the growth of complexity in the relationships of concepts in our applications. That is, I would say, one justification given for SOA. Like that's the kind of developer affordance justification for SOA, which is basically like, oh, like it's hard for us to like cooperate in a big app. And so that's why we did SOA. There's another one that I have more respect for, which is like there's dramatic technical differences between different domains. That's a much better justification. So like this would be like, actually Twitter is probably a good example of this, like where it's like 99% of Twitter API calls are like get timeline, and 1% are get post or are like post tweet or something like that. And you really like, in some sense, you maybe have different rates of change. Like the get timeline operation doesn't change hardly ever, and it's like 99% of traffic, and it's super stable, and you really want to make sure it doesn't break. And maybe you're like constantly adding new features to like the get post route. And again, it's only 1% of the traffic, and it's a different rate of change. It might make sense in that world to separate them into different services, right? Just because you want to untangle the failure domain. You want to make it so that a failure, like someone writes some bad code in the post new tweet application, you don't want that to take down the read timeline application. That's I think a more respectable justification. When people are kind of like, no, it's because we can't manage internal complexity in our applications, we have to break it down. I think my question would be like, how many people are on your team? And if it's less than 100, I'm like, you're not trying. That's the high level thesis of this talk, but I want to make it more productive. So I'll talk about how do we actually do it, right? Okay, so these are the problems with SOA, right? I'm gonna have a brief interlude before I move on. So there's a really good talk by this guy, Rich Hickey, who invented the Clojure programming language. We're called Simple Made Easy. I think it's the most influential technical talk I've ever watched on me personally. In it, he kind of unpacks two different distinctions that I think are really important for us to think about as engineers. So the first one is essential complexity versus incidental complexity. Every application we work on has a business, I'm calling it a business, it could be whatever, but it has a business domain, right? And that domain has complexity to it, right? If you're building a system that does someone's taxes, the tax code is complicated and you have to handle lots of if statements and corner cases and that sort of thing. That's intrinsic to what you're trying to do. That's essential complexity. Incidental complexity is complexity that you as an engineer create when you are trying to go build the application and do the thing that you're trying to do. Incidental complexity is your fault. And incidental complexity is kind of like, oh, like, I don't know, it's all the stuff that we were just talking about. It's sort of like self-inflicted problems that are the result of techniques we use to control other things. Lots of developer stuff like brings with it incidental complexity, and it's inevitable. Like you can't like totally hide this stuff away. But it's worth thinking about kind of like what is the real thing that we like a long-term effective development team is going to be good at handling essential complexity and is going to be very good at minimizing incidental complexity, right? We want as few kind of times when we trip ourselves up and give ourselves more problems as possible. The other distinction that Hickey introduces in the talk is simple versus easy. This is more of like a cultural concept, but I think it actually is a big kind of like light bulb if you kind of get it. Something is simple when it's kind of unencumbered, when it's like straightforward, it's direct. He used the word elegant. I think it's maybe a little loaded, but it's something kind of like very directly addresses the thing you're doing. That's a simple relationship, right? Simple is like an objective quality, right? A thing is either simple or it's not. It's not like simple to me, complicated to you. So like in the way I'm using the term. Easy, on the other hand, is sort of like near at hand. It's low effort. It's familiar. It's already known. Easy is like a relative concept, right? Making Google Slides is easy for me because as a manager, it was all I did for a long time. So I'm really experienced at it. It doesn't necessarily mean that, that's like, not to say that other things maybe it's harder for you all because you don't do that sort of thing. Easy is a relative thing. The key point here is that software developer culture conflates these two concepts really, really systematically in a way that makes it hard to disentangle what from what. The main example I'll give of this is like getting started with a tool or with a framework or something like that. How many times, and like everyone has done this, by the way, How many times does this happen where it's like, you are like, all right, I've got some problem. Like, I don't know, I've got to handle like currency math in a way that I didn't anticipate. And I want to be really precise. And I go online and like, hey, there's a gem that's like, do really good floating point or decimal math with currencies. And I'm like, gem install currency math. And guess what? Like the README is just like really straightforward. I can immediately get going. Cool, I'm off to the races right away. Does that mean that it is a well-designed gem? Does it mean that the internals of it make sense? That it's kind of like a straightforward and direct way of addressing the problem? No. What that means is the gem was easy for me. It was straightforward for me to learn to like I could get started really fast, like go, 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 great? That's ease. That's not the same thing as simplicity. Simplicity is a more kind of like, you have to study it a bit and you realize, yes, okay, this is a good way of addressing this problem, right? So the reason I bring up this distinction is that it's like, I do think this kind of applies in the SOA world, where it's kind of like, it's kind of easy to be like Rails new, like other application, right? And then copy paste some files and like, all right, cool, we're good. I think it's like in the long run simpler to kind of do the work of thinking through the dependency relationships and concepts you have in your application in a way that gives you leverage to kind of like take advantage of it. That's the, I mean, obviously this is a somewhat polemic talk, but like I do think this distinction is worth kind of meditating on a little bit. It's like, how much are we entranced by just like, you can get going so fast. And that just means the system that you're getting going on is good. It's not really the best proxy actually for this is a good system. Okay. Yeah, that's the guy with the doc. It's good. Okay, so that's all a way of kind of giving a motivation and then thinking of like, okay, well, how do we actually do this, right? So you're telling me that like you should build just one big Rails app, and that if you do some technique, question mark profit, what's the thing that allows you to actually do this well? And this is what we call the modular monolith. So the basic idea is that rather than having just this strictly horizontal orientation of code definitions, we want to also introduce a kind of notion of verticality to it, where we're going to have modules. Module can be either a Rails engine. Who here knows what a Rails engine is, by the way? Yeah. So it's like a Rails engine is basically like a sub Rails application inside of the main one. It can be kind of mounted at the route level or not, like into the router. And then you kind of like, okay, mount this engine into my router, then it has like all this functionality. But it's fundamentally a gem. It's like a gem that you install into the app that has some like particular interfaces. So module can be either an engine or just like a gem. By gem, I mean like kind of like a stateless gem, like something that kind of just has like some cool logic that you wrote that's like handles something. But we're gonna organize almost all of our code, 99% of our code, into either engines or gems, into these modules. Then we will create a dependency tree between these modules that will enforce at the bundler level. That is to say that there's kind of going to be like, there'll be like a users module. Maybe users is just an engine. And then there'll be like an API module that depends on that. Because of that, it's a bundler level dependency. You know that the users module cannot have code that imports the API level one, right? Because bundler won't allow you to have a circular import. So you know that you have a tree structure, and that expresses how your domain concepts relate to each other. Now, domain concept is doing some work there. It can be both like models level domain concepts, or it could also be like kind of strata, right? It could be like API versus core logic, that sort of thing. We actually do both at Tegus. Okay, so this is kind of just to get a bit more specific. We first tried this out. We kind of had honestly ignored the analytics thing because we deleted it pretty soon. We didn't like it. We had like three concepts. We have like a core that's like all of our business logic. This is when the company was like a year old. We had like 4 or 5 engineers. Core had like almost all our business logic, but we noticed that there was this subset of logic called conferencing that was all about like telephony and integrating with Twilio. And that basically that was like a somewhat closed unit. Like there were things that used it. But in particular, it relied on some core concepts like calls and users and so forth. But nothing really referenced those things. It was like an independent like module that interacts with Twilio, basically. And then we had an API. And so the first thing we did actually was pull out core from like everything from the API. So we set it up so that nothing in the core layer then can reference, even knows about the fact that there is an API. Then we extracted the conferencing logic. And look at the arrows are notable here. So it's like core doesn't know that there is a conferencing module. Conferencing module knows about core, but it doesn't know there's a GraphQL API. GraphQL API, because it's kind of at the top of the stack, it knows about everything. It's importing everything which makes sense, right? Because your entrance point, like people send in a request, you have to then invoke the next level and the next level. So it makes sense that like the entrance point is going to import everything into it. But the advantage here is developing inside of core, and to a certain extent inside of conferencing. The surface area of concepts you have to think about if you're working in the core module here is much smaller than if this was all put together in one area. Because you know that all of this code cannot be referenced at all by the core module. So you might as well just like, oh, it's not there, whatever it is. I mean, you have to you build to a certain internal, API in the sense of like Ruby to Ruby class distinction, but it's much easier. And if you can keep going, so you can keep slicing things out. This is not real. This is like based on my memory and like aspiration. So like Adam's gonna be like, it's not exactly like that, but it's like, it's close enough. So it's like what we ended up with like later on, and by the way, this is like probably half as many as there actually are, but I didn't want to like make this slide illegible. So what we actually ended up with, like, okay, there's a module called Prelude. What does Prelude do? Prelude is like, I don't know, it's fundamental stuff that isn't really tied to like a model, like a database-backed model. It would be things like inflections, I don't know, like clock configuration, how do we do UTC stuff here? Like whatever, like any sort of like totally global, just like concepts that are going to crop up throughout the app. Then there's like a users thing. And users, it turns out everything the app knows about a user, right? Like most things have like a user FK, right, relationship to them. But what's interesting here is you put this here, users don't know about anything else. This kind of means that all of our like our Rails relationships and associations, they're actually one directional, because the user model can't, it's not allowed to know that it has a relationship with like tweets or whatever, if you imagine that. A little bit of a constraint, but it's like not one that really causes that many problems. Again, the benefit here is that like, when you're working in this, you don't have to think about like nearly as much stuff. And then, on and on and on. So, the research module doesn't know about these APIs that express research, doesn't know about conferencing. It does know about these things, right? There's also a nice distinction here. That, like the way I thought about it was like a blue box is kind of like domain modeling oriented. So this is like code that doesn't really have an external facing API or external facing thing, but it's imported by things that do. And then the green boxes are kind of like stuff that like has an external interaction. So like notifications, for example, probably sends email, right? Or webhooks or whatever it is. And the APIs do their thing. And so, the rule here would be like a blue box can never import a green box, right? Would be the rule. It's making sense so far as like a concept. I will say, like, to be a little bit whatever about this, there's a degree to which this is like reinventing module systems that exist in most compiled languages, like so Java or Go or whatever kind of does this automatically. But it's a really powerful technique. Cool. Okay, so what are the benefits? So the main one is that it's in the mind of the developer on your team. They have to think about like, where does this go? Right? And when they're kind of building a new feature, they have to think about like, okay, what's the way to express this feature, ideally without introducing new dependency relationships in my domain. Sometimes they're unavoidable, right? Sometimes it actually just makes sense. It makes sense to say most things know about users, right? That's not like that's essential complexity, right? But maybe, if we had an arrow between like, oh, the AI gateway has to know about the follows system. It's like, I'll call that like, well, does it? Like, if we think about it, does it? Maybe you can minimize, by defaulting to not allowed to do something means that you often end up with like way less of that stuff than if you default to being permissive. The boundaries are clear, and this is a really, really critical point, they are easy to change. All of these boxes are in the same Git repository. And literally, they are just like the folder structure of that repository. If you copy and paste, or sorry, cut and paste some files from one to another, you change the topology of the boxes. Imagine how different that is from a service-oriented architecture. Who here has been in a situation where you're like, okay, you get down, you break out your app into services, and they're data persistent services. You got your user for service and follow service and dog service, whatever it is. And you realize, oh crap, this concept that we put in this service should actually have been expressed in this other service. How do you fix that? Well, you have to definitely move some code. So there's still some copy and pasting files. There's also a data migration. And it's a data migration between live systems. So there's going to be a data migration with a delta. And it's a much more involved process to move domain concepts between services when you realize you need to refactor them than between this, where it's literally just in the same code base. You literally just move the files and you're done. So the boundaries are expressed nicely, but they're changeable, which means that you can evolve the system more nicely as you go. This next bullet is actually the thing that got me really excited about this as a concept, and it's why I kind of push the team to end up adopting it. You can do differential analysis of what tests you need to run. So think about it like this. Okay, this is my import graph, right? If I work on the research code base, right? So I run git diff, and the only files that have changed are in the research, the research module. Is it possible I have broken the experts module? No, right? Because it's a one-way import. So when I'm running the test for the exports module, I don't even have research loaded, which means that if I just modify research, I don't need to run the experts tests. So in our CI system, we literally do a thing where we look at the commit that comes in, and we say what parts of the application did it touch, and based on the kind of iron hard rigidity of bundler not allowing circular import dependencies, we can say, oh, okay, all you did was change the API. I don't have to run any of the core system tests because it's not possible for you to broken any of them. So that's a huge win. I mean, it's both a win in terms of literally just speeding up CI, which of course is always a perennial battle, but it's also a win in just from again, think about the weight off your mind, right? It's I can't have broken all these other parts of the code because it's literally they're not imported when I'm working on them. That's kind of nice. I should mention, obviously if you change users, you have to run all the tests, right? So it's not oh, you don't run any tests ever. It's sometimes you do still have to run all the tests. There's some concepts also that when you do this, you have to mark certain types of ideas as global. So any change on the database schema, for example, you would say we have to run all the tests, right? But when you're just doing certain types of Ruby level modifications, it's yeah, whatever. And you have a single deployment artifact. Really, the core of a lot of problems with SOA is that you have multiple deployment artifacts, and here you only have one. Okay, so how do you actually do this? That's where we want to get to. That's the concept. How do you actually, at a technical level, do this? There are two techniques. We did one, and then I think now in 2025, I realized that there's another one that's better. We did this with Bundler, right? So we did this with we really hacked up our bundler and gem file, and when you run bundle install at the Tegus mono repo, it is not doing a normal thing. There's a lot of custom code that goes into it to enforce this stuff. That's one way of doing it, and it did work. It took a while, but it works. You have to think carefully about okay, when you get a third-party dependency, where does that come in? Is that a global thing? Is it attached to a specific engine? Whatever it is. Shopify did basically the exact same concept, but they implemented it with a different overall strategy. Shopify's approach is basically linting based. So what they do is they say they still have a concept of module, but the enforcement of module import boundaries is not done by bundler. It's done by a tailor-made linter that basically says hey, if you try to, I'm saying linter, but I just mean something that scans the AST. They say if you're trying to import a thing that's importing you with some in your modules requirement statements and so forth, then that's going to cause an error, and we're not going to let you run the app. I think that on balance, that's to use a concept, I think it's a slightly simpler way of expressing things because it is bundlers just basically can get hard to manage with what the approach that we took. So if I was to do this again in 2025, again, I would have like the same goals. I might use the thing that Shopify open sourced to do this. By the way, if you click through that link, Shopify is like decomposing their monolith, right? So they're not like, oh, we're gonna, but here's the thing, Shopify has like 4,000 engineers. So it's like, yeah, at a certain point, I think it's like, it makes sense. They've also been in business for 2 decades, at that point, your domain boundaries are fairly stable, I would hope. So, I'm not saying this works forever, but it's like, I don't know, does this room have that problem yet? Like, probably not. Testing is an interesting one with the engine thing. So what we do is we have like Rails tests require you have like an application running. So what we do is we have like a dummy application that has like no code in it. And then, if I'm running a test in research, it mounts research and its dependencies as an engine and then runs the test on that. And so then you have pure, you have guaranteed isolation. You also have this nice quality, which is that like literally loading that code in test is faster than it would be if you read the entire application. So there's some testing speed up because there's just less code. There's literally less code under test, but you've done this in a way that you can actually be confident that you're still exercising the parts of the system you need to exercise in a given test. Yeah, and then there's stuff like that. There's like the database is, you have to treat it as a global. There's certain other things you have to treat as globals, like certain configuration variables that Rails offers that if you change them, it can break everything. So you have to run all the tests when you change them. Cool. Config is a global, that sort of thing. And then, yeah, certain globals you can kind of put into like the Prelude engine, which is like configures everything. Yeah. That all making sense so far? I mean, maybe not like you're not visually exactly the lines of code that do this stuff, but the strategy, like the approach that you're going to take makes sense. Yeah. Okay. So what are the downsides? I mean, the downside is like at some level, this is a whole lot of like hacking out the way Rails works, like with the idea that like conceptually, hopefully this pays off in the long run. If the app is going to stay small, like small in terms of number of developers, number of modules, number of concepts, maybe it's overkill, right? But if you were starting a company and you're like, yeah, my vision is that this company is going to grow and like be used by a lot of people and there's been a lot of people working on it and so forth, I think that you should like early on, and we did this early on, consider kind of like, what do I want our system for organizing code and concepts to look like in 3 years? Assuming we're successful, right? I think this is a pretty good answer to that question. I think it's a better answer than kind of, we'll have 17 services. Okay. So yeah, just to kind of give a couple more slides and just like being able to benefit from hindsight. Tegus, I mean, like life throws you funny curveballs. So Tegus originally was a bunch of people who were Rails veterans and we're kind of like, all right, we're gonna build, we have this shared concept and like kind of, this would be really cool to have this nice to work in like Rails application, that sort of thing. Then from between 2019 and 2024 or 23, Tegus bought 3 more companies and all 3 of those companies use Python as their main language, which drove me insane because like my philosophy as an engineering leader is that it's like I'm really sensitive to having a narrow tool chain. Like I want to be able to solve as many problems as I can with the fewest number of tools as I can, because that's how you avoid like, oh, I switched teams and now I have to learn Clojure. Like, or like, oh, these people are using Mongo, these people are using DynamoDB, like they're functionally identical in their capabilities. Why are we doing this? Like, so I really always wanted, I was like, okay, let's keep the toolchain small. And then it's like, Ruby and Python are like very similar. Like in programming language vector space, they're right on top of each other, right? So this was annoying, but whatever, we're fine. We managed it. This did kind of mean that we became a service-oriented company without anyone ever saying like, get in it, right? There was no new code base created. We acquired the code bases. So we have started to deal with those problems as Adam mentioned, like we have not even fully solved them, right? Yeah. I don't know why I listed out the downsides again. We have multiple programming languages, and then you have multiple versions of programming languages. And famously, Python version upgrades are not like, the most fun things. Like, okay. So in conclusion, I have 2 conclusion slides. I do think the SOA should approach with care. I had, like last week, I had a Portco CTO ask me to when to consider microservices. And I'd just be like, when you have more than 100 devs, like That's my kind of like, you can disagree with a number, but like that's my like overall like starting stance, you know, and maybe you find other specific technical reasons that it's wrong. But you know, that's where I start. I started just writing full sentences in the slides. If you're feeling the pain from complexity and coupling your application, you can systematically address that complexity while staying within the confines of a single deployment artifact. This is almost always better than having more than one deployment artifact. Yes, that is a conclusion I have. And then, yeah, just some takeaways for everyone. You know, I'll make this into a PDF and then we can send it out. But yeah, everyone should watch Simple Made Easy. It's like a 35-minute video. It's very good. Hickey's a really good speaker. And then Shopify did a very similar thing, but like I think that their tactics were better. They did it. Actually, I don't know when their project started, but yeah, I think their tactics, like in retrospect, I would switch to those tactics. And also, I want to give some credit to Dan Mangus, who was my boss at Braintree, who like kind of had the same exact experience of like leaving Braintree and being like, I really like Rails, but we need to do it differently. And they did this set of techniques at Root Insurance, which was very successful, IPO'd and then crashed, but whatever, such is life. I don't think it's because their Rails application was bad. So yeah, so he wrote a good blog post that kind of covers this, similar concepts. I think the blog post is from like 2018. So it's like, this has been kind of bouncing around. So yeah, let's do some questions. All right, Adam, and then Joshua. You want to?
Yeah, you touched a little bit on how sort of more traditional languages often have their own sort of access limitations, whether it's through a module system or something like public and private members, which Ruby has too, but are not heavily used. And it sort of reminded me of what I think is a little bit of a weakness in our particular implementation of this, which is that when you import a lower level, you have access to all of it. And so sort of all of the public APIs of every class in the module that you're relying on, you have access to. So rather than those layers exposing explicit APIs to each other, do you have any thoughts about that?
There's a degree to which this entire talk is just like, there's this concept in object-oriented programming called encapsulation, and you should like think about it and apply it. Yeah, two thoughts. One is it's like, yeah, the Ruby encapsulation programming constructs are weak for two reasons. One is that they apply at the class level, whereas we're kind of talking at the package level to switch to like Java terminology. The other is that they're circumventable. You can famously just do send on the method name and it gets around like the private keyword in Ruby, which is, you know, like obviously you would hopefully just yell at someone to try to do that. But like, yeah, like, and I don't want to be a total downer, but it's like, yes, this talk is about how to implement constructs that other programming languages have by default by hacking up bundler. That's like another alternate way to think about the talk. To the point about public and private APIs, absolutely right. So Root Insurance looked at that problem and figured out their approach to it, which was, this is kind of like why I think the linting thing might be kind of like better in the long run. What I think Root and Shopify did, again, slightly different ways of expressing it, was their concept of module evolved to the point where it also includes kind of a definition of the public accessible methods of that module. So in other words, it's like you have a gem, like that is, and gem is like a Rails engine, and it's like, all right, a bunch of models and a couple, you know, whatever it is, and it's getting imported into some other thing. That thing that's being imported will also have somewhere, and I think again, between Shopify and Root, how they did this change, but somewhere it expresses like, these are the public access methods. Like this, you know, and like a good example to think about this might be like maybe most of your data is stored in Postgres, but you also use Elasticsearch for search, right? And so you have like a Ruby code bunch that sits on top of Elasticsearch and knows how to do Elasticsearch in your domain like language, right? In your domain concepts and how to look it up. It would be nice if you could kind of say like the 3 access levels, like sorry, the 3 methods for doing Elasticsearch are like this, this, and this. And then the thing that's using you doesn't have to be like, okay, I've actually imported all this code and like I can call anything I want. It's just like, these are the 3 things. And you have that enforced by whatever implementation you're doing. So again, I think Shopify, this was like very natural for them because they're just doing linting anyways. So it's like, it's pretty natural to extend linting rules to be like, yes, define somewhere like this is the access methods, and we'll just lint away that like you can't call anything else. I think, I don't know, I forget how Root, I think what Root did was they actually had 2 levels of module. They had like the module itself, and then they had like the public module, and you were only allowed to like talk to methods in the public module. It's a bit more it's a bit clumsier.
Would you be able to go back to the slide with the tree of dependencies, users down to API, please? I just had a question about like segmenting out your testing. You mentioned you could, if you change the API, you can just test the API. Could you ever run into a situation where, you know, there'd be other problems going on, but I'm just like throwing something out. You could change the API to where you could update the user and, you know, maybe add a string where a method is expecting an integer that would then cause something in the user model to fail? Yeah, so I mean, you know, this requires other things to be going wrong, but like, let's say you change your API to, say on your user's model, you have what age they are, and somehow you change the API to allow somebody to update the string of the year of, you know, saying 25 as opposed to the number. And then, you know, that could cause issues with the user model. Is that something you have to look into, or like?
Yeah, I guess, so I think the situation you're describing is that the API lets you smuggle data in a way that's bad, and then like later on or at some lower level, the bad data causes a problem. I think that the assertion that I'm making about testing is kind of like the tests you have on the user level are not going to change their output. I would think of it that way. It's like you change some code in the API, and it's like the API is importing the user's modules. The user's module doesn't import the API code. So the user's level code has not changed. So the tests that live like, you know, side by side with the user level code and test that code, they're not going to change their output, if that makes sense. So it's more of, in like, I do think that I mean, I don't know, systems can be weird and Ruby is very flexible. So you can probably construct a situation where, you know, like something escapes containment. But the claim I would make is that there's no point in running the user level tests. User level tests are not going to change in what they give you because they're unaware of the code change you made. Yeah.
Thank you.
Yeah, the question is, do we have integration tests that go over everything, all the layers? So there's sort of, I think I would say 2. So 2 ways. One is that like tests that executes on this level is going to execute, it's going to run all of this code. So it, you know, depending on your definition of an integration test, I would sort of say like tests at the API level are executing the entire program. You might still want kind of like router level tests, right? That also go through the whole HTTP stack, that sort of thing. We do have those, but they're not. Yeah, they're minimal. Most of the like domain logic tests exist that are integration-y exist at the API level, like the API module, I should say. Yeah. Yeah.
Did you say that you like started this like all the way from the beginning, or was this something where you guys started as like a small monolith and then like as like the domain grow? Like my ultimate question really is like, say you start as just a straight monolith, like what are some good guidelines for recognizing like a good time to maybe shift, migrate?
Yeah, so the historical answer is we did this when we had about 4 or 5 engineers, which is early, right? But I would say it's those 4 or 5 people, myself included, all came from the same other company where we all had the same like negative experience with like a gigantic uncontrolled Rails application. So we were ready to go with something like this, like before a similar group of people without that kind of like prior experience would have been. as far as like, so I think it's like, I don't know, you can make your own judgment. I would say if this was easier to implement and get working, that would push the boundary of like when you should do it earlier. But because it is a little bit hard to hack up like right now, I mean, I don't know, maybe it's possible that like I've not tried this. It's possible that the Packwork gem just like is great and just like works out of the box and like whatever is cool. So you could try that. Anyways, go ahead. Yeah.
If I drew a connection diagram between all the classes in my application, does it look like a rat's nest or not? Like how many times all the lines cross each other? Like how connected is the graph? And if the answer is, yeah, it's starting to get a little dense, it's time to do it. And it doesn't, I think the earlier you think about that, the better, whatever your solution is. Also, if you don't already have that written, probably right, or you do right.
I think Adam's answer there like directly gets at your final question, which is like when do you kind of like start worrying about this stuff? It's like I would say like even if you're not doing the technique, like I think an awareness of like the problems that motivate the technique is still helpful. Like just be like, oh yeah, crap, everything's talking to everything. Even if I'm not going full modular monolith per the talk, I could still like think about how to unwind that. Yeah.
Also, there's a really great talk on Shopify's Packwork from Boulder, what's it called? The Boulder Ruby, Rocky Mountain Ruby. Yeah, from 2023. So.
Yeah, I would, if I was going to just do this all over again, I would probably just use it. Yeah. I do think it's like not a coincidence that a lot of people who were building larger Rails applications like kind of came up with like similar ideas. I think it's almost weird that GitHub doesn't have one of these in a wild way because like Shopify and GitHub are like the two largest apps in the world, I think pretty undisputably. So yeah, I don't know. GitHub just lives with it.
Yeah, I have a question. Like, did you to do it in Braintree when you was in Braintree?
Yeah. Yeah, the question is, did we try to do this technique at Braintree? I think the answer is basically no. But what they did was they tried to break, they had maybe like 200 or 300 devs, and they were like, we're going to break apart the monolith. And so they had a large, and I would say very senior team, like a lot of the best engineers in Braintree just worked on breaking the monolith apart for several years. I think Adam was involved in that. And like, it worked. I mean, like, I don't know.
Some parts were super successful and some parts were complete failures. Yeah, it was sort of a rewrite project where we managed to take the good parts from the rewrite and incorporate them back into the system. We didn't move back to a monolith, but we did sort of re-examine our decisions about where the boundaries should be. And we got a lot out of it, but there was also, tens of thousands of engineer hours of work that ultimately did not make it to production.
Yeah, I very distinctly remember there was a moment, this was when I was kind of like a budding middle manager, like I was like running a couple teams, but hadn't really started to understand how some of the stuff yet. And like my boss, who was the head of engineering, I was like, kind of like, we have to do this project that I've got this great idea. This is all like our backend system. So it's like, I wanted to like change the way we did risk and credit underwriting and stuff like that. I've got this like really, it's like blah, blah. And my boss like just like sat me down. He was like, the decomposition project destroyed the credibility of the engineering team. We can't, like, I'm not going to advocate for this thing because everyone thinks I'm an idiot, on the executive team. Like, it's like, that was the way he phrased it. And it was like, yeah, like that can be an outcome of like trying to decompose your monolith. Braintree, by the way, is a very successful company, a great place to work to this day. But it's like, that was a hump, but that's a circa 2017 hump, right? It's not like a, permanent thing. Are you working there now? No.
You work at Braintree?
Fun. Hopefully you can validate what I just said. Yeah, I think it's a good company, but yeah, this is all the previous generation, I guess, from your perspective. Yeah.
Why you didn't do it before?
Yeah, a lot of companies kind of came up with this type of technique, I would say, in like the late 2010s. Around the time that people started to get interested in like, what's the gradual typing project called again? Sorbet, yeah. Things like Sorbet were getting started around the same era, that sort of thing. I think Braintree does use Sorbet now, right? Or no? Yeah. Yeah, cool. Yeah. What else? These are great questions.
I have two questions. So the first one is, do I understand correctly that your current code base is a monolith that has this nested modules, yeah? So it's one single application. And second question, do you advocate for this approach as kind of better alternative for service architecture? Or would you say that it's still like a matter of the specific case, and in some cases you will go with service architecture, and in some cases you will prefer to go with this nested modules approach?
Yeah, it's a totally fair question. You might want to, yeah. If you, okay, cool. So I think that's in the case of services, it is often very justifiable to do them when there's like big differences in terms of the technical requirements of different sides of the system you're building. So I mentioned kind of like this idea of like Twitter being like very read heavy. So maybe you have the reads be a separate service than the writes. You know, another example would be like, I don't know, Ruby is like a relatively slow memory intensive language. Like what if you knew that you had like a really intensive, like thousands of bajillions of API calls that don't do very much? Maybe you write that in like Go or something like that and you have that off to the side. So if there's like a genuine, like real difference in material technical needs, I think that can be a pretty good justification for having separate services. But like if you're using the same language and framework for two different services, that like I'm kind of like, okay, the motivation for doing that then is necessarily basically like we could not contain the complexity of the system domain inside of one application. Or I mean, like, frankly, I think I've seen people do services because like they can't handle personnel problems. It's like these two developers hate each other. Let's have them be on a separate service. And it's just like, I think that's honestly like, I think that there's like a spectrum of like dealing with like the code inside your service. And like, that's one extreme. And then the other extreme is like it's a hairball. Let's just like break into services. I think that whole spectrum is like, I tend to think is a weaker justification. And given that service-oriented architectures have well-known high costs in terms of operational complexity, I think that those weaker justifications, I tend to think are not very good. So that is a long way of saying, in some cases, I do think it's like, it just makes sense. Like, it's like, I'm not going to argue with it. But in a lot of cases, like social reasons are like the dumbest reasons. So just to like get like an actual manager in there and sort it out or whatever it is. But even like kind of like code complexity reasons, I think I'm skeptical of. Thanks. How do I send out the slides?